Hello, this is the live session for Structure, Form and Architecture, the Synergy. The course instructor for this NPTEL course is Professor Shubhaji Sadhu Khan from IIT Roorkee, and I am Shreya Shukla. I am the course TA for this course. I am a PhD scholar at IIT Roorkee. This live session is for week 3, assignment 3, and we will wait for 5 minutes for others to join, and then we will start with the live session. We will wait 5 minutes for everyone to join, then we will start the session. So it has been 5 minutes. Others will join. We are not waiting anymore. We will start with the session. So again, hello to all those who have joined. This is the live session for structure, form and architecture, the synergy. And today we are doing the live session for week 3, assignment 3. So these terms we have already talked about in the past 2 lectures. I will not be discussing them again. I've just kept them in the PPT just in case anybody ever wants to understand this. Now coming to the week 3 syllabus. So we covered 5 lectures were covered in this course in week 3. Basic structural properties, structural requirements, structural arrangement, structural forms and shapes, and structural materials. So starting with this is the 11th to 15th lecture, week 3. So every week we cover 5 lectures each. So in lecture 11, which is the basic structural properties, so in the lecture 11, basic structural properties, structural properties, we covered topics like force and moment. We covered topics about force and moment. We covered in detail, in definitions and detail about force and moment. And then we saw all those things, all the properties of force, along with different kinds of examples, which was covered in this. Then we covered the topic about static equilibrium, which I will be discussing because of a question later in this session. And then we talked about the different kinds of forces: compression, tension, bending, torsion, shear. Then we talked about then it was talked about stress and strain in that. So moving forward to the next lecture, L12, structural requirements. So in this lecture, equilibrium was covered, geometric stability was covered, strength and rigidity was covered. Stability is basically to resist any kind of displacement, the overturning, collapse or buckling, and all those things were discussed in detail with the help of figures. Then in lecture 30, structural arrangement. So in that lecture it was talked about how the structural supports were and how the structural supports affects the analysis and design and also the performance of building structures. So the different kinds of structural support that were discussed were roller, pinned and rigid kind of structural supports. Then we talked. Then it was talked about different kinds of combination of structural, like the wall slab, post lintel, post beam, and post slab. All things were discussed in detail. Then in lecture 14, which was structural forms and shapes, it was covered that the different. It was talked about the shape of the structure, the importance of the shape of structure with respect to the applied loads, and then it was talked about how structural efficiency varies with these different kinds of forms and applied loads. So 3 parts were discussed in details in that, which was form active, semi-form active and non-form active. So form active is basically when the load is coincident on the principal axis. Non-form active is basically when load is perpendicular to the principal axis, and semi-form active is when it is acting in different directions, especially in inclined direction. So there is axial force also and there is perpendicular force also. Then the last lecture was structural materials, and then it was talked about what is the importance of different kinds of structures in the selection of materials for different kinds of structures. Then it was talked about how the strength of material is directly related to the load and load carrying potential, and which indirectly affects the heights and spans we can achieve with different kinds of materials. And then there were some properties that were discussed which basically help you decide the kind of material that you are supposed to use for your structure. So these properties are strength, density, hardness, toughness, ductility, brittleness, elasticity. All these terms were discussed in detail. And then so yeah, so strength is basically the ability to stand load, and density is mass upon volume. Hardness is to resist the permanent deformness. Ductility is to deform without fracture. Brittleness is to break without deforming. Elasticity is to deform with the applied load and then return back to the original shape. And then toughness is to resist fractures when the structure is stressed. And then different kinds of materials were talked about: timber, masonry, concrete, steel, and RCC. Different kinds of composite RCC were talked about: glass fiber reinforced concrete, carbon fiber reinforced concrete, and others. And then it was also talked about what kind of material is good in what way. For example, your masonry is compressive in nature, your concrete is also compressive in nature, while steel has high tension, provides high tension, but it is also compressive in nature. And then RCC, we have tension and compression both in high limbs. So all these parts were covered. So moving on to our first question. I am I'm reminding everyone this again, that these are all previous year questions. These are not this year's question. We will not be solving this year's question. You have to do those on your own. These are just previous year questions to help you understand the course better and to help you understand how to decode these questions and how to solve them. So the first question is, force is an action. Just a second. So force is an action on an object that tends to change the shape of the object, move the object, change the motion of the object, or all of the above. So in mechanics, force has been defined as any kind of action that tends to maintain or alter the motion of a body, or it distorts it. In physics, a force is an influence that causes the motion of an object with mass to change its velocity, that is, it makes it accelerate. So force is basically mass into acceleration. So it can be a push force, it can be a pull force, but it always has some kind of magnitude and it always has some kind of direction. Excuse me. And the concept of force is commonly explained in sciences in terms of Isaac Newton's 3 laws of motion. We're not going in detail with that. And force is measured in a SI unit of Newton, and it is represented by the symbol F. And it is basically an external agent, and it is capable of changing a body's state of rest or motion. So if a body is at rest or if a body is at motion, when you apply a force, you can make the resting body move or you can stop the moving body. So force is capable of all those things. It's an external agent, it's an action, it's an influence, whatever term you can call it. It's a load. So force has different kinds of effects, and here are some of them. So force can make a body that is at rest to move. So if a body is at rest, force can make that body move. For example, when you're pushing something, you're pushing a box or something. Second, it can stop a moving body or slow it down. So for example, you are in a car and you put the brakes, you're putting a force, and then the entire mechanism in the car, it puts a force on that and the car stops. Third is it can accelerate the speed of a moving body. For example, you are on a cycle, and the more push you give, the more force you put on the pedals, the more acceleration you can get with that cycle. Fourth, it can change the direction of a moving body. For example, in sports, when a ball is coming to a batsman, the batsman hits the ball and it goes in a different direction. Or when a football comes to players, they deflect the football in different directions. So you can change the direction and of a moving body, and you can also change the shape. For example, you put a pressure on spring, you put a pressure on something sponge, you can change the shape. So you can change the shape for time being, you can change the shape permanently. All these are different kinds of effects that force has. So force that changes shape. So these are some of the examples where we are showing how force changes shape. So for example, spring, but then spring goes back to its shape. Then you can have a plasticine, it's like a clay, and then a sponge, it again retains shape. Then you can dent a metal if you hit it, and even a balloon, when you press it, it deforms, but then it regains its shape. So these are various examples where the objects are sometimes not regaining their shape and sometimes they're regaining shape. Second is force can make a body move. So when you put force on an object, you get some kind of motion in that body, and these kind of forces can act in two parts. You can push an object or you can pull an object to move the object. So force can be used to move the object. Third is, how does force change the direction of the object? So like I just told you the example of the batsman. So the ball comes, and then when the batsman hits it, it changes direction and it moves from the bat away from the batter. So the force is making the direction change on the ball. And then the example of cycle, for example, you're moving in one direction and then you put some force, you turn your handle and you move in another direction. So you're using force to change directions again. And this is just a graphic regarding the balanced forces where two people are pushing and pulling together. So the forces are balanced and the rope is neither moving there or there, it's just in center, and it's a very tensioned rope. There is tension in this rope and this is being balanced out here. So the answer is all of the above. It can change the shape of the object, it can move the object, it can change the motion of the object. Moving on to the next question, what should be the weight of the box B to obtain a static equilibrium in the following case? So we have been given a figure where there is a seesaw kind of situation where two boxes are kept at two ends and there is one pinpoint where it is and the distances are different for both the boxes. So it has been asked that what should be the weight B so that it stays in static equilibrium. So for that we will discuss static equilibrium first. So what is static equilibrium? So basically in the state of static equilibrium, the resultant of the forces, the resultant of the forces and moments equals 0, which basically means that all the forces that are being applied in a system are 0 when you add those forces. All the moments you add are also 0. And equilibrium means that also means that the system is not in motion and the system is not rotating. Nothing is happening. It's in complete equilibrium. All the forces are 0, so there is no motion and there is no rotation. So how we signify this equilibrium scientifically is we write summation H equals 0, which is basically all the horizontal forces that are acting on that system must be equal to 0. Summation V equals 0, which means all the vertical forces that are acting on that system must be equal to 0. And then summation M basically means all the net moments that are acting on that system is 0. So summation M is also 0. So because we have discussed about force, now we'll talk about moment. So what exactly is moment? So moment is basically the turning effect of force. So moment of force, it is a measure of its tendency to cause a body to rotate about a specific point of axis. So basically there is a point and then there is a line of axis over here, and you put force on this point and you make the object move along this specific point. So this is called moment. It is also called torque, it is called moment of force, it is called moment. These are the three terms that how we donate it. So in order for a moment to develop, the force must act upon the body in such a manner that the body would begin to twist. And this occurs every time a force is applied so that it does not pass through the centroid of the body. And a moment is due to a force not having an equal and opposite force directly along the line of action. Also, it is basically the product of force that is being applied on this body multiplied by the perpendicular distance from the line of action, which is from here to the pivot point, which is from here. So this line into the applied force is what gives you moment, and the SI unit of moment is Newton meter, and moment is basically force into distance, or F into d. So this is a very easy example to make you understand what moment is. So there is the screw which has been put there, and then we're moving the wrench, we're putting force on it, and which is causing the moment to happen. So next is, when you see this image, you understand that this question is actually about moment, because we are seeing weight which is causing the load, and we are seeing also distance. So moving forward, it was asked that it should be in a state of equilibrium. So let's say that this is just an example figure which I am putting here with variables. So let's say that at point 1, the force is acting, which is F1, and A is your pivot, or where the this structure is fixed, it's the pivot, and then the distance of pivot and the point P1 where the force is acting, the distance is d1. So let's say the torque or the moment that is happening at this point P1 is F1 d1. Like we just talked about, that it is distance into force. Then we see that T2, which is acting at point 2, so the force that is being acting at point 2, and the distance from the pivot is d2. So the moment on this point is F2 d2. Now we learned this, that in a static equilibrium state, all kinds of forces must be zero. The summation of all kinds of forces must be zero. Forces are not zero. Forces are there, but all these forces, all these moments are cancelling each other out. That's why there is equilibrium. So that, which means it said that all the summation of all the moment is also zero. So summation of all those moments is also 0. So that means T1 acting at P1 and T2 acting at P2, both the summation of those would be 0. Now we convert T1 and T2 in F1 D1. So why one of these forces is written in minus is because one is anti-clockwise and one is clockwise, and when you are adding up forces, you have to write them in the same motion. So if one of the forces is acting in a different direction, then you have to write that force in minus. So that's why it's minus F1 D1 and plus F2 D2, which means that F1 D1 is equal to F2 D2. So this is how we arrived at this question. Now looking back at this question, now we know that F1 D1 is equal to F2 D2, which has arrived from the equation that all the moments would be 0, which means T1 and T2 would be 0. So coming here, F1 D1 equals F2 D2. So force, here we have the weight, not exactly the force, but we are using weight here. So the weight is 50 and we are multiplying it with the distance, which is 8. And this should be equal to 2, and B, which is the weight of the, let's assume B is the weight of that other box. So when you solve this equation, you get B equals 400 by 2, which means B must be 200 kgs. So this is how you solve this kind of question. So our answer is C, 200 kgs. So if this box is 200 kgs, this system would be in static equilibrium. If it was more than 200 kgs, it would fall down in the direction of B. If it was less than 200 kgs, it will fall down in the direction of A. So to achieve the equilibrium, it has to be 200 kgs. moving to the third question. What type of force is acting towards the direction of arrow in the given example? So, and the options that are given here are compression, shear, tension and torsion. So to be able to answer this question, we should be knowing all these four kinds of forces. So we have compression, shear, tension and torsion, and we have this image. So what is compression force or compressive force? It basically, this force occurs when a physical force presses inwards on an object. For example, this is your object and you are putting it inward, the pressure is being put in inward, which is causing this object to compact, and this is called compressive force. So in this process, what happens is that the relative position of atoms and molecules inside the object, when you are compressing the object, when you are putting a lot of force on the object, they change, they become more compact, which is why it compresses, it compacts. So this change can be temporary and can be permanent, like we discussed. Like for example, spring, when you compress, it again comes back, so it's temporary. While if you're putting compressive force on steel a lot with something and it's a permanent deformation, so that happens. So basically it depends on the kind of material and how that material will act to this kind of force. Now shear force. So shear force is a force acting in the direction that is parallel to a surface or a cross section of body, like the pressure of airflow over an airplane. For example, this is a body, so the shear force would be acting parallelly to this. So this is shear force when it is acting parallelly to the surface. So, and the word shear in the term is a reference to the fact that such a force can cut or shear through the surface of an object under strain. For example, this is an object, and when you're putting a stress or force on it like this, it can make the object to shear. Basically, shearing means dividing in two parts. So it can make the object shear, it can make the object cut, so that's why it's called shear force. Tension. So tension is basically described as the pulling force transmitted axially by the means of a string, a rope, chain or a similar object, or by the end of a rod, a truss member or a 3D object. So it can be basically described as the action-reaction pair of forces acting at each end of said elements. So what happens? Compression is pushing, tension is pulling. So if this is an object and you pull it in both the directions, that is called tension. That is the kind of tension force we're putting on it. Madan, you can type the question in the chat box. I will answer it in some time. Then torsion. So basically what happens in torsion is that if a load is applied on a material, it will create shear stress, which induces torsional force, and when this force is large enough, it causes the material to twist, and this twisting force is called torsion force basically. So now to show you some examples, and this here first image that has been given is basically, oh okay, no problem. So the first image, it basically shows, I think it's a concrete block, and they're trying to show how concrete would work in tension and compression and shear. So as you can see, in tension you're pulling it apart so that it's breaking. In compression you're pushing it together, so it's breaking like that. And in shear, it's the force is right parallel to the object, which is making the object cut in half or share apart. And then these are some of the examples of compression. So you can see the compression and spring, which I have mentioned. And then this tension force, two people pulling on the rope, is creating tension in the rope, and this is happening. And then a very common example for torsion is our clothes. we are twisting the clothes, which is releasing the water. So it's a very everyday life examples of torsion, shear, compression, and tension. And this is a simplified figure for the four terms. So it's the same object, which is the same rectangle and four kinds of forces. It is being shown here, all the four kinds of forces that are happening here. Just a second. So when tension is being applied to that rectangular box, what is happening is it is getting stretched. So it is getting thin in middle, it is getting stretched. When compression is being applied, it is getting thick in the middle because it is getting compacted. When shear is being applied, it is sliding, it is dividing in two parts. And when torsion is being applied, it is twisting. So this is how the shape of the structure would change with these different kind of forces. So again, our question was that when you look at this image, what kind of force is happening over here? So it's very clear from what we have understood now that it is a shear force, because it is splitting it in two parts and the force is happening in two parts. So basically it is tearing it apart. Coming back to question 4, lateral instability in structure is also known as buckling, displacement, stiffness, and rigidity. Excuse me. So lateral instability in a structure is also known as buckling, displacement, stiffness, and rigidity. So to be able to answer this question, we should be understanding all or what all these four terms mean. I'm sorry for the use of occasional Hindi words. It's in a habit of speaking that it happens. In case somebody, I'm really sorry for using them. I will try to communicate only in English so that everybody can understand from all over India who has joined this course. Yeah, so we will talk about all these four terms so that we can answer this question. So like I mentioned, the NPTEL lectures talked about geometric stability. So geometric stability is basically to retain the shape without any deformation. For example, there is a geometric shape, so the shape of that, for example, you took a geometric shape, it's a square. So because of all the acting forces, it does not become a parallelogram or other things. That is geometric stability. It stays in the shape it was being made, and it is necessary to guarantee equilibrium. So basically, geometric stability is defined as the property of a structure which preserves its geometry under loads and allows the structure to act as a unified system. And the NPTEL lecture, it covers that stability is broadly defined as capacity to resist displacement, overturning, collapse, and buckling. These are four kinds of things that happen to structures, and if the structure is able to resist all these four things, then it is stable in nature. So because overturning and collapse are not in this question, I'm not covering them in detail. I'm covering the two terms which were mentioned in this in detail. So we'll talk about buckling. So what happens in buckling is basically buckling is the sudden change in the shape of a structural component under load, such as the bowing of a column under compression or the wrinkling of a plate under shear. It is also called lateral instability. So what happens in buckling is that an axial force is acting on a column, and instead of being compressed, it buckles, it bends. So the load is so much, and because of the property of the material, there are millions of many reasons which are happening here. So it bends, it buckles, rather than being compressed like we saw in the example before. It bends. So that is buckling. What is displacement? Displacement is basically displacement in the building from one position to another due to an external force like wind or earthquake. So displacement is not like very significant displacement that happens because of wind. or earthquake, but yeah, there is a very minimal, some millimeters itself, the displacement happens, which can uh, ruin the structural integrity of a structure. So that is displacement, when even in some millimeters the structure is being displaced because of external forces like wind, like earthquake. So the structure, any kind of structure, they should be able to resist displacement when these kind of external forces happen. Stiffness. So what is stiffness? Is actually the extent to which an object can resist deformation in response to an applied force. So you are applying a force to an object and the object is resisting deformation. It is resisting the change in shape to your applied force. That is stiffness. That is the quality which is called stiffness. So, and the opposite concept of stiffness is flexibility or pliability. So basically what it means, flexibility means, is that the object can deform when you are applying force to it, but it regains it back later. That is called flexibility. And stiffness is that you are applying a kind of force on your object, but it is not deforming at all. It is resisting the deformation. So the more flexible an object is, the less stiff it is. More stiff the object is, the less flexible it is. That's how it works. When talking about rigidity, it is basically the property of a structure that it does not bend or flex under an applied force. So stiffness and rigidity are somewhere similar terms. Basically they mean that rigidity means that the structure is not bending or flexing under an applied force. So the question was, the lateral instability in a structure is known as buckling, displacement, stiffness and rigidity. And we just discussed that buckling is also called lateral instability. So the answer is buckling. I'm sorry, my mouth is really getting dehydrated today. So question number 5, we have, in a pin type structural support, in a pin type structural support, horizontal movement is free but vertical movement is fixed. Horizontal movement is fixed but the vertical movement is free. Both horizontal and movements are fixed. Both horizontal and vertical movements are free. So to be able to answer that, we should know what is pin type of structural support. So yeah, Rishi, you can leave your question in the chat box. I will answer it later. So pinned supports are referred to as hinge supports, and it is the most common type of support in civil engineering. So pinned support, it does not allow movement either vertically or horizontally. So basically structures, two elements of structures are joined. They're joined by a pinned support. So the movement does not allow it to move horizontally and it does not allow it to move vertically. So both of these movements are restricted. However, it is allowed to rotate. So a pinned support can resist both vertical and horizontal forces, but not a moment. So it resists vertical and horizontal forces. It does not resist a moment because it is free to move, it is free to rotate. So it does not resist a movement. And they will allow the structural member to rotate, but not to translate in any direction. Translate in any direction means to move in any direction. So in most cases, a pinned support only allows for twisting in one direction. So yeah, these are some of the examples of pinned kind of supports, and these are some of the symbols that are used for pinned kind of supports. So basically what happens is that you cannot move horizontally, you cannot move vertically, but you can rotate. So this is a pinned support. So the answer would be In a pin type structural support, both horizontal and vertical movement are fixed. Rotation is allowed, but vertical and horizontal movements are fixed. Moving on to next question. In which of the following structural support type the rotation is free? Okay, Rishi. You don't need to raise hand for answering the question. I am anyway discussing the question and answer would be available. If you still wish to answer, you can write it in the chat box. In which of the following structural supports, sorry, in which of the following structural support type the rotation is free? We have a roller type, we have pin type, and third option is both A and B, and the fourth option is none of the above. So to be able to answer that, we should be understanding roller type and pin type. So basically, the support types, there are four: roller, fixed, pinned, and simple. But simple is not a structural type, so we're not discussing simple here. We'll discuss the other three. So what happens in roller supports? So roller supports are free to rotate, and they're free to move along the surface upon which the roller rests. So roller supports are located at one end of the long bridges usually. That's where the roller supports are used. And this allows the bridge to expand and contract with the temperature change. And the expansion forces could fracture the supports at the banks if the bridge structure were locked in place. For example, there is a bridge structure and at the bank of a river or whatever water body it is. If it was a fixed structure, so because of temperature changes, the material that the bridge is being made of, it will expand or contract depending on the temperature. It will contract in cold weather, it will expand in heat in warm weather. So when that happens, these roller kind of supports, it allows the bridge to slightly move a little, which helps the bridge stay there. If it was a fixed thing and if the material was expanding, then there is a chance of a fracture happening or a crack happening. This is why roller supports are used in such cases. It can also take the form of rubber bearings. Matlab basically we use rubber bearings, rockers, gears, balls, whichever, to design a roller support and to allow a limited amount of lateral movement. I'm not saying that because of the roller or whatever kind of bearing that is being provided that the lateral movement is allowed a lot. It is not allowed a lot. It is a limited amount of lateral movement, but some amount of it is allowed. Then in fixed supports, I have this table, I'll show you. In fixed support, what happens, it can resist vertical and horizontal forces as well as the moment. And since they restrain both rotation and translation meaning movement, they are known as rigid supports. So fixed supports are only called rigid supports. This means that a structure only needs one fixed support in order to be stable. All three equations of equilibrium can be satisfied, and because it does not allow, it resists vertical, horizontal as well as moment forces, so all three equations, summation H, summation V and summation F, are of equilibrium are satisfied here. And next example is a flagpole set into a concrete base is a good example of this kind of support. So it's fixed. You can't have a horizontal movement, you can't have a vertical movement, you can't have a moment, nothing. It's fixed, and it's fixed in all forms. Next is our pinned support. We just discussed about pinned support, but I would cover the example that has been given. So pinned support can resist vertical and horizontal forces but not a moment. We just discussed that. They allow the structural member to rotate but not to move in any direction. And a very organic example has been given, which is the knee. It can be idealized as a connection which allows rotation in only one direction and provides resistance to lateral movement. So these are three kinds of examples that I have added here to show you. So the first is a fixed example. So it's basically it's fixed. The flagpole is in concrete. There is no kind of movement allowed and there is no moment allowed also. Second is your pinned support, in which you can see it is joined with the help of a pin. I think that's why that it is called pinned support, so that in case of expansion or contraction it can move a little slightly. And the third is roll. You can see the bearings there in that kind of support, which allows the structure to move vertically, horizontally also. No, yeah. So this is a table to help you understand it in detail in a better way. So fixed support, this is how we donate fixed support, and it allows movement in no direction, and it restricts movements in vertical direction, horizontal direction, and it also restricts rotation. Pinned support, it allows movement in rotation about the supported location, and it restricts movement in vertical direction and horizontal direction. And then the roller support, it allows the movement in horizontal direction, and it also allows the movement in rotation about the supported location. It restricts the movement in vertical direction. So vertical direction, the movement in vertical direction is restricted in all kind of support types. So our question was, in which of the following structural support type the rotation is free? Basically, the rotation is free. So rotation is free in both pin and roller support. So the answer would be both A and B. It is not free in fixed support, but it is free in pin support and roller support. Question number 7. The St. Louis Gateway Arch in USA is an example of what shape? So, Madan, if you want to say something, you can please type in the chat box. Please don't turn the mic on in between the session, because the session is also being recorded to be uploaded later for so that other students can access it later. So yeah, whatever doubts you all have, please put it in the chat box. Thank you. Yeah, so St. Louis Gateway Arch in USA is an example of what kind of shape. So this was covered in the 4th lecture, where it was talked about form active, semi-form active, non-form active, and I will briefly talk about all these forms so that we can answer this question. So first of all, this is the St. Louis Gateway Arch in US. It is 192-meter tall. It's just a monument. It does not serve any other kind of purpose. 192-meter or 630 feet tall, you can say. It is located in St. Louis, Missouri, United States. It is clad entirely in stainless steel. It is built in the form of catenary arch. Catenary arch is basically a kind of arch in which I can't explain it with hands. You can read about it later. So basically, for example, this is a strip of an arch and it's a little bent inwards. So that is called a catenary arch. You can look it up. It is world's tallest arch. It was built in 1965. The architectural style that this monument covers is actually modern architecture and high-tech architecture. And it was built by Eero Saarinen, and he's a Finnish-American architect. He's a very famous architect. We also covered one of his buildings, the TWA terminal at the John F. Kennedy Airport in New York, in the first lecture. So yeah, this is all about the structure. Now we will understand what is form active, non-form active, semi-form active. So basically the concept, the form active concept, is an essential aid for assessing the efficiency of structural form. Basically this was developed to assess the efficiency of structural form. And with the help of this concept, all buildings can be classified in three categories. And basically, buildings in the sense that the structures that are being used in those buildings, which indicate the type of internal forces that will occur within them. So this criteria, this category has been established in the terms of the internal forces that are happening on those structures. So for form active structures, it covers structures like domes, arches, cable nets, tension fabrics, etc., that are sometimes flexible and either shaped or materials such that under load no bending stress exists, only compression and tension stresses. So the first type is form active structures, and in form active structures only compressive and tension stresses are happening. Compressive stresses are there, tension forces are there. There is no bending that is happening here. There is no bending happening in these kind of structures. Second category is non-form active. This kind of structures, the internal force is purely bending. It does not include compression, tension, axial, any kind of stress or strain. It is purely bending. It just bends. And non-form active elements are beams, basically horizontal stuff like beams, slabs, others. Then semi-formative structures have a geometry that does not fit in post and beam kind of structure and does not fit in form-active structures which are like domes, tension, cables and arches and other things. So basically the elements that are there in form-active, semi-form-active kind of structures contain a range of internal forces. They have axial forces also, they have shear forces also, they have bending forces also. Basically, semi-form active refers to elements that combine axial and bending stresses. Now looking back again at this monument, this St. Louis Gateway Arch, you can see that it's an arch. And we just learned that the form active structures which have only compressive and compression and tension stresses happening to them, and no bending forces, and the elements that are available are domes, arches and other things. So it's quite evident that this structure would be form active structure. Moving on to the next question. We will take a break at 7 for 5 minutes and then we will join back in 5 minutes. So this would be the last question that I do before the break, and then we will take a break and we will continue again. I have 15 questions for this live session. After that we will have the Q&A round and you can ask your doubts and I would try to answer your doubts in all my capacity, and if I'm not able to answer, I'll try to answer your questions in the next class. Which reminds me, in last class one question Rishi had asked regarding the brickwork, and I would answer that at the end of this session. Yeah, so in an object, the property of the material having the ability to deform without fracture is called what? So here we are talking about the property of the material in which it deforms, but it deforms without fracture. So we have 4 terms given here. We will discuss about all the 4 terms and then we will answer this question. So the 4 terms that are given here are toughness, hardness, brittleness and ductility. What is toughness? So toughness is, just a second. Toughness is the ability of a material to resist fracture when stressed. So stress is basically amount of energy absorbed per unit volume, energy or force per unit volume. It is the ability of a material to absorb energy and plastically deform without fracturing. So toughness basically means it deforms but it does not fracture. Hardness is the ability of a material to resist permanent deformation under a sharp load applied on the structure. So hardness means when you are applying a force on the structure, there is no deformation that is happening. The property of the material is that it is not allowing any kind of deformation. It is also referred to as stiffness. It is also called temper, and it provides resistance to bending, scratching, abrasion or cutting. And the greater the hardness of the material, the greater the resistance it has to deformation. Ductility is the property of a material having ability to deform without fracture. Materials with high ductility are preferred as they are more able to indicate structural failure without a sudden collapse. So it deforms, you're putting a force, the structure is deforming without fracture. So this is ductility. Brittleness is the property of a material where material breaks easily without significant deformation. So deformation doesn't happen in brittleness. Structure itself breaks. For example, if a structure or a material, sorry, not a structure, a material is brittle in nature, so you put some kind of load in it, it fractures. It does not deform, it fractures. That is called brittleness. So materials with brittleness absorb relatively less energy prior to fracture, even those of high strength. So we understood all those terms, and then the question was the property of the material having the ability to deform without fracture is called. So the answer is ductility. We're on question 9 now. We'll take a break for 5 minutes. I'll join back in 5 minutes. Hi everyone, we are resuming the session. Um, Question number 9, GRFC used in building construction. What does it stand for? The options are gypsum fiber reinforced concrete, glass fiber reinforced concrete, glass free reinforced concrete, or gypsum free reinforced concrete. So the answer actually is glass fiber reinforced concrete, because all the other kinds of terms, they don't exist. So I'm not explaining all those points, but I will give some facts about glass fiber reinforced concrete, what it is, so that you can remember a few important or interesting facts about GFRC. So glass fiber reinforced concrete, GFRC, it comprises of hydration products of cement or cement plus sand and the glass fibers. And glass fibers are used as reinforcement in this kind of concrete. So it is a material that is building a substantial influence on the economics, technology and aesthetics of the building industry worldwide for over 40 years. It's been 40 years this is in play. And GRFC, sorry, I'm again calling it GRFC, GFRC is one of the most multi-purpose structure tools obtainable to architects and engineers. So it is available in the glass fibers are basically available in the forms of mats, wool, ropes, woven fabric, and it has a variety of applications. It can be used to fabricate interior countertops, floors, fireplaces, mantles, exterior window surrounded elements, facade wall panels, among other uses. On average, it has 2 to 4 times more flexural strength than the conventional unreinforced concrete, and basically which means that JFRC is stronger and more flexible than your regular concrete, and while the reinforced concrete, unreinforced concrete is weaker and more brittle. So basically what is happening is it's concrete, it's a composite kind of concrete which has glass fibers being used as reinforcement. These are some of the images that I could procure of GFRC. So in the first images you can see that it is being used as ropes or just like a thing there, and then in the second image you can see GFRC, there is a shear layer which is being added in the concrete, a mat kind of structure which is being added. So we already discussed this. The answer is glass fiber reinforced concrete. Question number 10. Arrange the following forms from high to low structural efficiency. So we talked about form active, semi-form active and non-form active structures, and I would like to tell you one thing about them is that the structural efficiency of form active is the highest, non-form active is the least, and and semi-form active is somewhere in the middle. So the options we have here is trussed portal, steel truss, shell and RCC lap. We'll just quickly see what all these structures mean, and then we will try to arrange them on the basis of structural efficiency. So trussed portal is basically a portal truss structure which is comprised of a set of braced columns that support an overhead truss. So what happens usually in truss is that there are columns, there are poles or columns, and then the truss over it, which is a framed structure with struts, is supported on it. What happens in portal frame or trussed portal or portal frame truss is that the columns also have this kind of bracing in it that we have in the truss. So that's why it's called portal frame truss. So that is portal frame truss for you. Then coming to steel truss. Steel roof truss is essentially a triangulated system of straight interconnected structural elements, and the individual elements are joined together at the nodes by welding. So these are struts which are joined together in this structural shape, and they're joined together by welding, and you can see the images below of a trussed frame and of a portal frame truss, and you can see the difference very clearly you can understand the difference from the images given. Next is the shell structure. Shell structure. So a shell structure is basically a thin curved plate structure, and it is shaped such that to transmit applied forces by compressive, tensile and shear stresses that act on the plane of the surface. So it's a very thin and it's a curved plate. It can exist in any kind of shape in curved plate. I've given some examples. It can exist as a barrel, a dome, hyperbola, and other things. So this is a shell structure. It is basically a very thin shell kind of thing, and usually it is available in the form of curve. And basically it tackles compressive and tensile and shear stresses that act on the plane of the surface. RCC slab, everybody knows it. If you are from civil engineering or architecture background, you would know what RCC slab is. It is just a structural component, and they are supported on the columns and beams. And I've just given a small example how bending happens in RCC slab. So now this is the image that was actually given in your NPTEL lecture. I have borrowed it from there. So it basically shows you, I have made it full screen so that you can show properly. This diagram basically shows the structural efficiency from high to low. So high is form active, then semi-form active, then non-form active. So we have already discussed what kind of elements, structural elements are covered in form active, semi-form active and non-form active. So in form active we have arches, shells, tension fabrics, cable nets. Then in semi-form active we have simple like a portal frame, and then we have improved, which is a trussed portal, and then we have non-form active, which has low structural efficiency. For example, the simple is a RCC slab or a timber joist, and then the improved one is a steel I section, steel and timber trusses, and other things. So now coming back to our question, we have to arrange them from high to low. So we have 4 points now. P is truss portal, steel truss, shell, and then RCC. Now we know that shells have the highest efficiency because they belong to form active. So R would be the first one. Then we just learned that trussed portal are improved, so they have better structural efficiency. Then P would be the one. Then we learned, according to this form, that trusses are important. Trusses have good structural. That means Q would be one, and then the last one would be RCC slab. So the answer is RPQS, arranged from high to low structural efficiency based on this specific figure. Question number 11. An object is said to be in static equilibrium when net horizontal forces must be equal to 0, net vertical forces must be equal to 0, net moments must be equal to 0, or all of the above together. So we have discussed about equilibrium in the lecture in the start. I'm just covering it again. So in a state of static equilibrium, the resultant of all forces and moments equals 0, which means that vector sum of all the forces and moments adds to 0. It does not have any kind of motion or any kind of rotation. Summation h is 0, summation v is 0, and summation m is also 0. So the answer is all of the above together. So your net horizontal forces are 0, your net vertical forces are 0, and your net moment is also 0. The structural arrangement of Villa Savoye, France is post beam, post lintel, post slab, or wall slab. So for being able to answer this, you should know what Villa Savoye looks like and what is actually Villa Savoye. It's one of the very famous buildings of Le Corbusier. I'll just show you in the next slide, and then we will talk about what these kind of structural arrangements are: post beam, post lintel, post slab, post wall slab, and then we will answer that question. So this is how Villa Savoye looks like. It is a modernist villa. It was built. It was designed by, not built by, designed by Swiss-French architect Le Corbusier. It was built between 1928 and 1931. It is an example of Le Corbu's 5 points for new construction. So Le Corbu has famously given his 5 points in architecture during his era when he was working on that, in which he said that these 5 things should be present in any kind of new construction from there on. It was his idea, it is not a said rule or something, but it was his idea that these 5 things should be there, which was pillars. And you could see that in his most of his architecture buildings. When you analyze them, you can see almost all of these features present, if not all, most are present usually. So first is pillars, then roof garden, open floor plan, and long windows and open facades. And this is a very famous building, and it's a renowned example of international style. So this is how Villa Savoy looks like. So what is wall slab structural system? So wall slab structural system, wall acts as vertical load bearing member and slab acts as horizontal load bearing member. And usually the walls in this case are shear walls. Post-lintel structural system, columns act as a vertical load-bearing member and lintel acts as a horizontal load-bearing member. Post-beam structural system, column acts as vertical load-bearing member and beam acts as a horizontal load-bearing member. Post-slab structural system, column acts as vertical load-bearing member and slab acts as horizontal load-bearing member. So it's very clear that how the arrangement between these structural systems works. So again, looking back at this, it is quite evident. It is quite evident. You can see in the ground floor there are a lot of columns, and then you can see the slab being supported by it. You do not see any beams here or any lintels here, which means it is the structure is directly being supported on columns. So the slab is being supported on columns. So the answer would be post slab. Question number 13. It's very similar to the question that I just showed you before. What should be the weight of the person B to obtain static equilibrium in the following? So they have given a structure. Two people are sitting on the end of this seesaw. A weighs 45 kg. We have to know the weight of the B. So here we will apply the summation of moments. Because it's in equilibrium, nobody's moving below or up, so it's in equilibrium. So we apply this thing where the torque or the moment that is happening at point P1 is F1 D1, and that happening at point 2 is F2 D2, and the summation of both these moments is 0 because the structural system is in equilibrium. And we derived this whole formula that F1 D1 is equal to F2 D2 from this, which is basically an easier way to solve these kind of questions if you get an exam. So F1 D1 equals F2 D2. F1 is 45 and the distance is 3 meters from the pivot, and B we don't know, and the distance is 5 meters from the pivot. And when you solve this, it becomes 135 divided by 5, carrying over 5 on the other side, and then you get B equals 27. So the answer would be 27. Another of the question based on height to low structural efficiency. Now we have 2 new terms and 2 old terms from the previous question. So P is membrane structure, Q is truss portal, which we just discussed. Then we have space frame, and then we have RCC slab, which we just discussed, and then we have all these options which we have to match. So because we covered truss portal and RCC slab, now we'll understand what is membrane structure and what is a space frame. So again, membrane structure is structure with a thin flexible surface. It's usually like a membrane, a sheet that carries loads primarily through tensile stresses. So the fabric is tensioned with the help of cables and poles, And the two main types of membrane structures are tent structures and pneumatic structures. And trust portal, we just discussed it, that the columns are also supported on columns are also braced in trussed portal. Space frame is a 3D truss. So we all know what a truss is, and you apply the truss to help support the roof. So space frame is basically a 3D truss. The entire truss is, you can, if you can visualize it in 3D, it's a space frame. You can see I have given the image over here. So the first images are of the membrane structure examples. You can see how the tension cable, the column and the mast and the sheet or the membrane is helping the membrane structure stand. Then you can see the portal frame truss, that the columns have bracings in them. Then we have space frame, which is basically a 3D truss. Space frames are usually rigid, they're lightweight, they are truss-like structures which are constructed from interlocking struts in a geometric pattern, and it can be used to large span areas with few interior supports. Then we have RCC slab, which is a structural component and are supported on the columns and beams. So again, going back to this image, and we know that your form active structures have high structural efficiency, your non-form active structures have low structural efficiency. And our question is membrane structure, which would go in form active, truss portal, which would go in semi-form active, space frame, which would again go in semi-form active, and then RCC slab. So and because we know truss portal is an improved kind of semi-form active because the columns are also braced, as you can see in this image. So the correct order would be P, Q, R and then S. So the correct answer is A, P1, Q2, R3, S4. Last question for today, and after that we will continue with Q&A. We will wait for 15 minutes for everyone to ask. Wait for 15 minutes in case anybody wants to answer it, ask any question, and then we will conclude the meeting. So torsion in a structure leads to shortening of structure, elongation of structure, twisting of structure, sliding of structure. So if you remember what I told you, those who have joined in between, they might not know, or they might have studied, so they might know the correct answer to this. So what does torsion really do? I provided an image where I showed how in one structural member, one cuboid, if you were applying compressive force or tension force or shear force, what was happening to that body. So coming back to this example again, you can see tension makes the structure elongate, compression makes the structure compact, shear makes the structure divide in two parts, and torsion makes the structure twist. So yeah, what does torsion do? Coming back to our question, torsion leads to twisting of the structure. So the answer would be C, twisting of the structure. So this is all for today. Please, you can ask your doubts and questions. We will stay on call. If anyone has any questions, you can please type it in the chat box. I will answer it. And to answer Rishi your previous question in the last class, yeah. So I was trying to read about it, but there was nothing clearly available on that specific question. But like I said last time, if it's a load bearing structure, if the wall is taking the load, then it makes the wall a structural member, which means that the wall is actually structure. And if it is a structure, then of course it can come in the category of structure as ornament. Not the first category, the second category. The second category being when the structure itself is an ornament. You don't have to do something over it. It itself is an ornament. So I think it would qualify in that category. Although I didn't find any kind of concrete evidence on it or any proof on it, or I could not find this example anywhere specifically. But I think it would fall in that category only and if and only if it is a load bearing structure. If it is If it is not a load bearing structure, if the wall is just acting as a horizontal surface, if it is not taking the load, then it won't go in structural element. Yeah, so you guys can ask questions. You can type your questions in the chat box. I would try to answer them however with whatever knowledge I have. Please, and we can stay in call. We will see for 15 minutes. If anyone has any questions, then we can leave. Fifth question. Let me see. Let me see the fifth question. Uh, this one you want? The pin type structure? This is the one, right? The pin type structure? In a pin type structural support, horizontal movement, it was asking if what is free and what is not free. To explain it easier, I will go to that table that I showed. Yeah, this one. So in pin type support, what happens is that so in pinned type of support, you cannot, the structure cannot move horizontally and the structure cannot move vertically. So these are two different kinds of structural members and they're joined together with the help of a pin. So it's called pin type of support. So it cannot move horizontally, it cannot go vertically. It can, however, rotate. So this is a pin type structure. Similarly, in rolled structure, what happens is it cannot go vertically. However, it can go horizontally because it is attached with a roll kind of thing, a bearing kind of thing, which can provide it movement. So it can move horizontally, but it cannot move vertically, and it can also move. It can also rotate. So that's a rolled structure. And in a fixed structure, it cannot move vertically, it cannot move horizontally, and it cannot rotate. It's fixed. So basically the question was asking, going back to the question. So the question was asking that in a pin type structural support, horizontal movement is free. Yes, it is. But vertical, so no. Horizontal movement is free, but it's free, but the vertical movement is fixed. No. Oh, I'm so sorry, I'm confusing you. Horizontal movement is free and vertical movement is fixed. No, that's not the case because horizontal movement is not free in pin support. And then the second point is asking that horizontal movement is fixed but vertical movement is free. That is not the case in any of the pin support. Vertical movement is not free in any kind of supports, be it rolled, be it pin type, be it fixed. Then both horizontal and vertical movement are fixed. Yes, It cannot move horizontally, it cannot move vertically, it can only rotate, pin type. So the option is C. And these are some of the examples. You can see this is how pin supports act. They're attached with the help of a pin, and the members and the both the members are attached with the help of a pin, which makes it easier to move. I hope it explained. Okay. We will stay on call for 5 more minutes. If anyone has any doubts, please ask, kindly ask. We will end the live session here. If you have any doubts, anybody has any doubts, you can ask me in the next class. Thank you, everyone.